What's up guys, welcome back to the channel. Today on this video we'll be doing this question paper that you see here. As you can see, this is a national certificate for mathematics and 5, and this question paper was actually written on the 27th of March 2026. It was an X paper that took 3 hours to be written. So on this specific video, we'll be focusing on question 3 of this question paper. If you haven't watched question 1 and question 2 of this question paper, I'll leave the playlist that contains those questions. You can go to the description and click on that link, and also the very same link will pop up at the top right of the video that you're watching. But before we start with question 3, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because we have made lots of videos on N5, N4, and also N3. All right guys, before we look at question 3, I'll leave the timestamps so that if you don't want to watch this question in a sequence order, you can go straight to the question that you would like to watch specifically. All right, let's look at question 3 and then let's solve it. All right, guys, here is our question 3. Now, as you can see, question 3 consists of 3.1, 3.2, and 3.3, with 3.1 having 4 sub questions. So we're going to start with 3.1 and then we're going to do other questions later on. So let me just create space and let's do 3.1.1. All right, guys, let's look at question 3.1.1. Now we'll start with question 3.1. 3.1, actually, we are given a function here. F of x is equal to x cubed plus x squared minus x minus 5. Now, question 3.1.1, they want us to determine the coordinates of the turning points of f of x. So this f of x there. Now, when you calculate the turning point of the cubic graph, because this is a cubic graph, you need to derive this function and equate it to 0. So let's derive this function here. We can write it like this: f of x prime is equal to 3x squared plus 2x minus 1. All this is equal to 0. Do not forget, guys, when you derive this, you must equate it to 0. That's how you're going to get the coordinate of the turning point. Right, so when it's like this, we can able to solve for x by factorization. Now we know that the factors of 3x squared is going to be 3x and x. If you multiply 3x and x, you will get 3x squared. And then we have the last term there, which is -1. The factors of 1 is actually 1 and 1. If you look at the term in the middle there, we have positive 2x there. So meaning this 3x must multiply with positive 1, and then this one is going to be negative. Then we can continue and write the following: 3x is equal to positive 1, and the other one is going to be x is equal to -1. What you did here, we transpose this -1 and positive 1 to the other side. But this one here, we are not looking for 3x, we're looking for x. So we have to divide by 3 throughout. If we divide by 3 throughout, we'll be left with x this side, and then this one is going to be 1 over 3. Or you can write 0,333. There we go. And this one is going to continue. X is equal to -1. So we have the x coordinates for this turning point. Now it's time for us to find the y coordinates of this turning point. So I'm going to do it here on the right. When x is equal to 1 over 3, we need to find out what is y. Right. So to find the y coordinate, you need to substitute the x value on the original equation there, or f of x. We can say y is equal to, wherever there is x, we're going to substitute with 1 over 3. Let's do it. We have x to the power of 3. We can write 1 over 3 to the power of 3, plus we have x squared. We can write 1 over 3 squared, minus we have x there. We can write 1 over 3 minus 5. There we go. Now you have to put this on a calculator. Now when I insert this on a calculator, what I'm getting here is actually -5,185. There we go. So this is y when x is 1 over 3. So you can say turning point 1 when x is 1 over 3, our y is going to be negative 5,185. There we go. This is turning point 1. Now we need to find turning point 2. Let me create a little bit of space here so that we can able to do that one. There we go. So we can say when x is equaling to negative 1. Remember now our x is going to be negative 1. We need to substitute this negative 1 wherever there is x on the original equation. So we can say y is equaling to, we have x cubed, the first term. Instead of writing x, we're going to write negative 1 cubed, plus we have x squared. Now we're going to write negative 1 then squared, minus x. Instead of writing x, we're going to write negative 1 minus 5. Then if we set this on the calculator, we get negative 4, right? So this says that when x is negative 1, our y is negative 4. So we can say turning point 2, when x is negative 1, our y is going to be negative 4. There we go. So this here and that one there, those are the turning points for this function there. So this is what they wanted us to calculate there. I hope you guys managed to understand how to calculate the turning point of this cubic graph there. First, you derive once, and then you equate to 0, and then you start solving for x, and then the x coordinates you substitute to the original, and then you get the y coordinate. That's it. All right, people, if this part of the video helped you to understand how to find the turning point of the cubic graph, please do not forget to like, share, comment, and subscribe. But if you got confused somewhere, go to the point where you got confused, rewatch at that point. All right, people, we are done with this 3.1.1. Let's go and do the next question, which is 3.1.2. All right, guys, here is our 3.1.2. Now here they want us to draw up a table of x and f of x, where x is ranging from x is equaling to negative 2 to x is equaling to 2. So basically here they want us to draw a table like that. There we go. And then we have to insert negative 2, negative 1, 0, 1, and 2. Remember, they say it ranges from negative 2 to positive 2 on x. Now, what we need to do here, we need to substitute these values on our f of x. If you still remember from the first question, our f of x is actually x cubed plus x squared minus x minus 5. This is actually our f of x. So what we have to do here, we have to substitute these values of x here on our original equation. So if we substitute negative 2 on this equation there, what is it that you're going to get? So if I use my calculator, I am getting negative 7 there, right? And then we move to the point where x is negative 1. If you substitute negative 1 here, what is our f of x there? So this is going to be negative 4. This reminds me of the turning point as well. If we substitute our x, which is 0 this time around, on these here, our f of x is going to be negative 5, right? And then we move to the point where x is 1. If we substitute 1 here, what is going to be our f of x? We are getting negative 4 as well. Now the last one, if we substitute positive 2 on this here, the answer there is going to be positive 5. There we go, guys. This is how you're supposed to do this one. Really, it was not that difficult. All you had to do here, guys, is just substitute the x values from negative 2 to positive 2 on this equation there, and then you insert your f of x values there, and that's it, guys. We are done with 3.1.2. If you manage to understand how to do this one, do not forget to like, share, comment, and subscribe to the channel, guys. So if it so happen that you did not understand, do not forget to watch at the point where you get lost, and if that doesn't help, you can always watch at the point where you got confused, or leave a comment there. All right, people, we are done with this question. Let's move to the next question, which is 3.1.3. All right, guys, let's look at 3.1.3. Now, they want us here to draw a new graph of f of x showing the turning points between these values. The values that they're talking about are the ones that are in the table here. We did this table on question 3.1.2. Now this is our f of x that they're talking about. So they want us to draw a graph then. So before we draw a graph, we need to write our turning points here. We have turning point 1. X is going to be 0, 33, and then our y is negative 5,185. There we go. And then turning point 2, where x is negative 1 and our y is negative 4. There we go. So from this, we can able to draw our graph. So before we draw our graph, let me draw the Cartesian plane, and then we start plotting our graph. All right, so here is our Cartesian plane, guys. Try to create it in a way that's going to be simple for us to draw the graph. So let's start with point 1 from our table there. When x is negative 2, our f of x, or y in this case, is going to be negative 7. Now here is our negative 2 there. You're going to take a ruler, you draw a line that is going downwards, and then our y is going to be negative 7. Negative 7, if you look at the y-axis on the negative side, negative 7 is between negative 8 and negative 6. So again, you take a ruler, you draw a line in the middle there, and there we go. Where they meet, that is going to be our point. Right, let's go to the second point. The second point is when x is negative 1, our f of x or y is going to be negative 4. So negative 1 on x is going to be here. We draw a line here using a ruler, and then we look at negative 4 on y-axis. Also, we draw a line there. Wherever they meet, this here is going to be our point. There we go. Let's move to this point here. When x is 0, our y is going to be negative 5. So negative 5, if we can look at y-axis, it's going to be between negative 4 and negative 6. And we all know that x is going to be 0 on y-axis. So here is our point there. Right. Now, when you look at this point here, when x is positive 1, our y is going to be negative 4, or f of x. So again, we're going to draw a line there passing at 1, and then we draw another line from negative 4 on y-axis, and then this here is going to be our point as well. Now we go to the last point from the table. When x is 2, our y is going to be positive 5. Now, wherever there is 2, we take a ruler, we draw a fainted line like that, right? And then we look at f of x or y. It's going to be 5. So 5 is between positive 6 and positive 4. So in the middle there, we're going to draw a line that is horizontal. Wherever they meet, this here is going to be our point. Now let's look at our turning point. Let's start with turning point 1. When x is 0, 33, our y is going to be negative 5,18. So 0, 33, it's somewhere between 0 and 1. So in the middle. So we draw again a line there. And then our y is going to be negative 5,1. Negative 5,1, it is a little bit less than this one here, lower than this one. So you draw a line there, and wherever they meet, this is going to be your turning point. Now you can do this to show this is the minimum turning point. Why is it minimum? Our y there, it's less than this one there. So it's going to be minimum, right? And then we look at this one as well. Turning point 2, when x is negative 1, y is going to be negative 4. This is the point there, guys. If you still remember, this here is the point. So this is the maximum turning point. So it's gonna look like that. Then from there, we start connecting the dot. Let me connect the dot. All right, so this here is our cubic graph. Guys, doesn't look that beautiful, but the aim here to actually have the shape with the right values there. So you have to name this graph f of x is equaling to x cubed plus x squared minus x minus 5. Right, and then you can also mention or name your turning point. This one is negative 1, and then negative 4, and that one here it's negative 0, 33, and then negative 5,185. There we go. So I hope, guys, you managed to understand this. It was a bit tricky if you don't know how to draw graphs, but really it was not that difficult. But if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you have a problem understanding this, you can always go to the point where you got lost, rewatch that point, And if that doesn't help, you can always leave a comment and I'll try to answer you to my level best. Guys, we are done with 3.1.3. Let's go and do the next question, which is 3.1.4. Right, guys, here's our 3.1.4. Let's read this statement and let's solve this problem here. Now we are given that the estimation of the root of the equation x cubed plus x squared minus x minus 5 is equaling to 0 is close to x is equaling to 1 comma 5. Use Taylor's or Newton's method twice to determine better approximation of the root. Provide the correct root in 3 decimal figures. Now here we are given an estimated root here, which is 1 comma 5 for x. So basically they say we need to find exactly what is this value here. The one that is being given to us as an estimation, it is somewhere there. It could be here, 0 comma 5 could be there, or it could be there. We don't really know exactly where is it, but it is very close to that point. So in order for us to find that, we need to use Taylor's method or Newton's method. So I'm going to zoom down so that we can able to solve this problem. Right. So I'm going to do it here on the left. So the Taylor's method or Newton's method, we have a formula for that. The formula goes like this. We have x n plus 1 is equal to x nth minus, open bracket, we have f of xn divided by f of xn prime. There we go, close bracket. So this formula here, we use it to actually find the one that is very close to our root there. Now we are given that x0 is equaling to 1 comma 5. There we go. So this is the one that is given to us. This is the same as x nth there, right? So let's continue. I'm going to write this formula in a way that is going to be easy for us to substitute. First of all, we have x0 plus 1, right, is equaling to x0 there, minus f of x0 divided by f of prime x0 there. There we go. Now that we know what x0 is, we can able to find our f of x0 and f of x prime 0. They are not that difficult. I'm going to do them here on top here. F of x0 is going to be, we're going to take this equation, the original equation, and substitute with our x0, which is 1 comma 5. So let's do it. So we have 1 comma 5 cubed plus, wherever there is x, we're going to put 1 comma 5, guys. 1 comma 5 squared minus 1 comma 5 minus 5. You put this on your calculator, whatever you get there, that is going to be your f of x0 there. So when you put this on a calculator, our answer is going to be negative 0.875. This is our f of x0. Now we need to find f of x0 prime. So f of x0 prime, now we have to derive the original equation. Remember, the first term we have x cubed. So when you derive x cubed, you're going to have 3x squared. You're going to write 3, but instead of writing x squared, we're going to write 1 comma 5 squared. There we go, plus. And in the second term, we know that it's x squared. When we derive x squared, this is going to be 2x. Instead of writing 2x though, we're going to write 2 multiplied by 1 comma 5. And then the third term is negative x. The derivative of negative x is going to be 1. So our final answer for this one is going to be 8.75. There we go. Now that we have our f of x prime 0 and f of x, we can able to substitute these there. I hope you guys can see what's happening there. Right, let's do it. So we can say x0 plus 1, this is the same as x1 then, is equaling to, but x0 we said is equaling to 1 comma 5. So let's write 1 comma 5 minus, open bracket. Now here we have to write f of x0. We know that f of x0, it was negative 0.75. So we're going to write negative 0.875. There we go. Divide by, we divide by f of x0 prime, which is this one here. So we write 8,75. Then we close bracket there. Now if you put this on our calculator, our answer here is gonna be 1,6. There we go. So our x1 is actually 1,6. Remember, they say we must use this Taylor's method or Newton's method twice. So this is the first one, meaning we need to find one for x2. So let's create space so that we can able to do for x2. So the formula for x2 is similar. We're gonna have xnth plus 1 is equaling to x1 minus, now open bracket, f of x1 over f of x prime 1. There we go. Now all you have to do now is to find f of x1 and f of x prime 1, because we already have x1 there, which is 1,6. All right, so we need to find our f of x1. So let's do it. F of x1 is going to be, wherever there is x, we substitute with 1,6. Remember, our formula says our first term is going to be x cubed. So instead of writing x cubed, you're going to write 1,6 cubed plus the second term is x squared. So you're going to write 1,6 squared. Then the third term is minus x. So you're going to write 1,6 minus 5. Then we put this on our calculator. F of x1 is going to be equaling to 0,056. There we go. Now it's time for us to find f of x1 prime. F of x1 prime there. There we go. So we have to derive the original equation. Like I said, the first term is going to be 3x squared, but we're going to write 3 multiplied by 1,6 squared, right? Plus, and then the second term is going to be 2x. This is going to be 2 multiplied by 1,6 minus 1. Then if you put this on a calculator, this is going to be equaling to 9,88. There we go. Now we have our f of x1 there and our f of x1 prime there, which you're going to substitute them there. And we know that x1 is equaling to 1,6. So let's substitute. Now if we substitute here, we have x nth, which is 1 plus 1. There we go. Is equaling to x1. Remember, x1 is 1,6 minus, open bracket, f of x1, which is 0,056, divided by f of x1 prime, which is 9,88. And then we close the bracket. And then when we continue here, x1 plus 1, that is going to be x2 there. And then you put everything inside the calculator. Our answer is 1,594. There we go, which is x2 approximate to 1,6, which is similar to x1. Then we stop here. This here is correct, guys, because when you use the Taylor's method or Newton's method, your x's, you stop when they are the same. So as you can see, this is one and the same thing, 1,6, both of them. Even though this one here, it is not exactly the same, but when you round it off, it's gonna give us 1,6. Guys, I hope you managed to understand this. This is not that difficult. It looks very difficult, but really it is really not that difficult. I hope you managed to understand this, and if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If you didn't manage to understand, you can always watch at the point where you got confused, and you can leave a comment at the comment section. All right, people, we are done with this question 3.1. Let's look at 3.2. All right, guys, let's look at 3.2. Now let's read the statement and solve this problem. It goes like this. A box with a square base and no top is to hold a volume of 100 centimeters cubed. Find the dimension of the box that will require the least material for the 5 sides. Now we are given the hint then. The volume, they say, is equaling to length squared multiplied by h, and the area is equaling to 4 length multiplied by height plus squared length. So this one here, they want us to use the maxima and the minima, but for the fact that they say least material here, that means that it's a minima, right? So we have to find the value of the length and the value of the height. We are given the value of the volume. As you can see here, we are given these formulas here, one for volume and one for area. So what we can do here, since volume is equaling to 100 centimeters cubed, So we can write this as 100 is equaling to length squared multiplied by h. And then we can make h subject of the formula. If we make h subject formula, we know that 100 is going to be divided by length squared is equaling to h, so that we can able to substitute this h to that formula there, so that we can be left with only length there on our right hand side of the area. So if we write this, we say area is equaling to 4 length. Wherever there is h, this h there, we substitute with 100 over length squared. So we're gonna multiply by 100 over length squared, close bracket, plus length squared. There we go. And then we need to simplify this further before we do anything. So area is going to be equaling to, we have length over length squared, so we actually left with 4 multiplied by 100, which is 400 divided by length, plus length squared, right? So from here we need to derive this. Remember, this is minimum material, so what we need to do here, we need to derive this and equate it to 0. But before we derive this, we can rewrite area as 400 length to the power of -1. If we take this length to the numerator, it's going to have the power of -1 plus length squared. There we go. Now let's derive. We derive area with respect to length. So dA over d length. What is our answer there? So the derivative of length to the power of -1, this is going to give us -400 length squared, the power. And then this one here is going to give us plus, and then this is going to be 2 length. There we go. This is going to be equaling to 0. Let's not forget minimum, guys, least material, right? So from here we can rewrite this. Let me do it on top there. We can say -400 divided by length squared. Remember, we have the power of -2 there, plus 2 length is equaling to 0. From here, we can simplify this and make it to be linear. We multiply by length squared throughout. So if you multiply by length squared throughout, this term here is going to be -400 plus, and then the second term is going to be 2 length cubed is equaling to 0. Right, from here, we just solve for length. If we transpose this -400 on the other side, you'll be left with 2 length cubed is equaling to 400. Then from there, we divide by 2. Length cubed is going to be equaling to 200. Then from there, we cube root both sides. Don't forget cube rooting. And then length is going to be 5,848 centimeter. Now that we managed to find the length, it's time for us to find the height. Remember, they want us to find the dimension of this box there. So if you still remember, we know that height is equaling to 100 over length squared. So we can write height is equaling to 100 over length squared. Instead of writing length squared, we're going to write 5,848 squared, and this is going to give us 2,924 centimeters. Guys, I hope again you managed to understand this. This was not that difficult. Once you find one variable, it's easier to find the next variable. All right, if this part of the video helped you to understand how to calculate these two dimensions here, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Right, if it so happened that did not understand, you can always leave a comment in the comment section, and also watch at the point where you got confused. We are done with this question, which is 3.2. Let's go and do the last question there, which is 3.3. All right, guys, let's look at 3.3. Suppose that the radius of a sphere is changing at an instantaneous rate of 0,1 centimeters per second. At what rate is the area of the sphere growing when r, or radius, is equaling to 10 centimeter? Hint, we are given that area is equaling to 4 pi r squared. So what's happening here, guys? We need to derive these, but now with respect to time. This is similar to when we are doing implicit derivative. So we have to derive dA over dt, right? And then we derive this radius with respect to time. So this is gonna be 4 pi multiplied by 2r multiplied by dr over dt. This is the rate that is given to us there with respect to time. So what we need to do here is continue and multiply them. If we multiply this, we have 2 multiplied by 4 pi. This is going to give us 8 pi. And then we have r, and we multiply by dr over dt, right? And then we start substituting. When we substitute, we have 8 pi. Remember, r is 10 centimeters. And then the rate of the radius there is 0.1 there. If you put this on your calculator, your answer is going to be 25,133 centimeter squared per sec. Do not forget, guys, it's centimeter squared because we are calculating the rate at which the area changes. Right, so this is how you do this last question here. I hope you guys managed to understand this one as well. If this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel. If you did not understand, you can leave a comment or watch at the point where you got confused. We are done with question 3, guys. I hope this question 3 was as simple for you to understand. Thank you very much, guys, for watching. Next time we will be doing question 4. Do not forget to like, comment, subscribe to the channel. Until next time, cheers.